Right, so we're going to look at the domain and the range of periodic functions. So the first thing we're going to do is put our calculator in radian mode. So if you put your mode key, you want to make sure that we're in radians. We're going to go down to parametric, which is right next to function. See it highlighted, hit enter. So I put myself in radian mode and parametric mode. I'm going to hit the y equals screen. Now the y equals screen is going to look different than it used to. It's going to have x sub 1t and y sub 1t. So in x sub 1t, we're going to put the cosine, and t is going to be the x button right next to the green alpha button. And then in y1, we're going to put the sine function. So sine and the x button again, which you'll put a t in that space for your angle. So that's step 2. Step 3, we're going to change the window settings for a parametric function. So we'll hit the window button. And it says make t min equal to 0, t max equal to 2 pi. The t step will make 0.1. My x values, I'm going to go x min of negative 1.5. X max is going to be 1.5 and a scale of 1. Keep entering. Y min is going to be negative 1. Y max will be positive 1 and a scale of 1. Okay, so it's the first 3 steps. Third step is graph the equations and describe the graph. So once you have that typed in, you can hit graph. And you see a unit circle. My radius for this unit circle is 1. So we did step 4. It says use the trace features to move the cursor around the graph. What do the t values represent? So we're going to use the cursor. And if we scroll around, so hit the trace button first. Scroll around, you can see you have a value for t, and a value for x, and a value for y. So as you scroll around there, you stop right at the top there, 90 degrees. 90 degrees is about, it's equal to pi over 2, which is about 1.57. Let's keep scrolling and see if we find something interesting. We keep scrolling around here. Let's stop at 180 degrees. All right, that's pretty close to 180 degrees. That's on the other side of 180 degrees. 180 degrees is pi, which is about 3.14, and our t value is about 3.1. So your t value is going to represent your angle. So my angle measures in radians. It's also, like we did yesterday, the length of the arc. So the distance around the outside of the circle matches the angle. What do the x and the y values represent? As we scroll around here, you can see those x values, those y values changing. Those x values are the values for the cosine for your angle t. Y values, the sine for that angle t. That's what we looked at yesterday. What are the least and greatest values for x and y? You can scroll around here. If I start back at the beginning again. It's back at the starting point. Starting point x is 1 and y is 0. If I scroll back up to 90 degrees, pi over 2. My y value is really close to 1. My x value is really close to 0. Okay, So 0 and 1 so far. Over here at 180 degrees at pi, my x value is down to about -1. My y value is just about 0. And down the bottom here at 270 degrees, which is about is 3 pi over 2. We're at about 0 and -1 for my x and my y coordinates. And then back at the beginning, we're back to 0 and 1. So my x value, my smallest x value was 0. Sorry, my smallest x value was actually -1. My largest x value is +1. My y value, smallest y value is -1. Largest y value is +1. It says, what's the domain and the range for the function of x? Well, the function of x, we said, was the cosine. So I'm not worried about what the y values are. The domain for my values for x, my cosine function, so we said the values for x went from -1 to +1. That's my domain. My range would be, what do I get when I plug in my -1 and +1? So my domain would be my t values. And the range would be my y values, my outcomes. Values went from 0 to 2 pi. For my y, my t values still went from 0 to 2 pi. The range, or the outcomes, went from -1 to 1. If I change 4 pi to 8 pi, my change this to 4 pi. That means when I scroll around here, I can scroll around here, oops, more than once. As I go around the second time, you can see the x values and the y values still range from -1 to +1. Okay, and when a function repeats itself after a certain value, then the value is called the period of the function. What's the period for the sine function? What's the period for the cosine function? So both of these we had to go around one time around that circle in order for it to repeat. So the distance around the circle was 2 pi radians, or if we were working in degrees, it would be 360 degrees. Okay. The next page of the notes deals with some identities. So the identities are for odd and even functions. So your trig functions have properties for odd and even values as well. So if my angle, which is my t, is a positive angle or a negative angle, if I say my angle is positive from here to here, is my angle t. If I go in the opposite direction the same amount, my angle would now be negative t. if I write the coordinates for this point, it's over some x value, it's up some y value. So I have x comma y for that point. This point down here is the same idea reflected over the x-axis there. It's still over x, but now it's down that same y value. So if I look at the cosine of angle t, I would have my x-coordinate. If I look at the cosine of negative t, it's still my x-coordinate, which is the same value there. So the cosine, whether the angle is positive or the angle is negative, I still end up with the same value. They're equivalent. Since the secant is just the reciprocal for cosine, it's going to be 1 over my x-coordinate. So if I look at the secant for angle t, I'm going to have 1 over x. If I look at the secant of negative t, I still have 1 over x. So it still gives me the same value when I look at the angle as a positive or a negative. So these two functions, cosine and secant, are both even functions. It didn't matter whether the thing that you put into the function was positive or negative, it gives you that same outcome. The sine, the tangent, the cosecant, and the cotangent are all negative odd functions. So if I look at my angle for t, if I look at angle t, my sine would be my y-coordinate. If I look at angle t is negative, so negative t, now my sine is negative y. It's the opposite. For tangent, I have y over x for angle t. If I look at negative t, my angle is now negative y over x. So the function became the opposite of the original function there. So it changed signs there. So the sign of a negative angle gives you the opposite of that original function. Same thing with tangent, gives you the opposite of that original function. Cosecant, cotangent, they're just the reciprocal of that original function. So if I looked at 1 over y, it would end up being 1 over negative y. Same thing for cotangent. So these are all odd functions. So what that will allow you to do, some of the problems, if you use those identities, the sine of t is 1/7. So using the identity, sine of negative t, if I go up here, equals negative sine t. If I know sine t is equal to 1/7, negative sine t would be negative 1/7. Look at this one. Cosecant of negative t, using this identity right here. Cosecant negative t equals negative cosecant t. Cosecant of t, from my directions here, I don't have cosecant, but I know the sine is 1 over 7, which means the cosecant would be 7 over 1. So I get negative 7. That's the reciprocal identities. For the cosine of negative t, so this identity here, no, that's not cosine. Here it is, up here. Cosine of t. Cosine of t equals cosine of negative t. It doesn't matter whether the angle is positive or negative. So if cosine of negative t is 1/3, that means the cosine of t has to be 1/3. And then for secant, let's get another color. So secant, whether the angle's positive or negative, we get the same outcome. So if I'm looking at secant of t, we get that same outcome. So the secant's the reciprocal for cosine. So if cosine is 1/3, the secant of negative t would have to be 3 over 1. So if secant of negative t is 3 over 1, the secant of positive t would also be 3 over 1, or just 3. So using those identities. These identities actually have to be memorized, so you can make some flashcards for those would be helpful.